Chapter 3 is all about our mathematical background for the rest of the year in chemistry. So it's all about our measurements. We are going to be taking measurements and using measurements for the rest of the year because we problem solve in this class. So the definition of measurement is a quantity that has both a number and a unit. Because of this, when we take measurements, we have to use a consistent, uniform method. And so the entire scientific community around the entire world uses what's called the International System of Units, or we call them SI units for short. And this is because if I write a scientific paper and then someone across the world, like let's say in China, reads it, well, yes, there's going to be some translation for our languages, but if I use SI units in my paper, then whoever's reading it is going to know exactly what my measurements stand for because it's the international method. So we have some SI units for different things. For example, length is in meters. The SI unit is meter. Volume is cubic meter. Mass is kilogram. Time is second. Temperature is Kelvin, which we haven't gotten to yet, but we're getting to this chapter. Energy is J for joule. That's coming up later on. And pressure is a Pascal, and that will also come up later. So these SI units of measure might show up on the test, maybe as a bonus question, where you have to tell me and identify what they are, in case you need to put a little note in your note packet for what that entails. So what we're first going to do is we're going to be converting between units, okay? This is our metric conversion line. Our metric conversion line is kind of like a number line, where it's going to help us to determine how many times I need to move my decimal in order to convert between the different types of units, okay? So a couple things on your handout that we should write down first. If you notice, this right here, right in the middle, it says base. These symbols, like the meter, the liter, the gram, the second, those are always going to be the second letter in your unit on the number, the label on the number, okay? Or if you only have one letter, then that would also be like base. The one letter. So if you need to write this down on your handout, go ahead and do that, okay? Everything else is going to be the prefix on your unit. So we might have milliliters or millimeters or centimeters. So the base is that second letter in our unit, but we could have cm, stands for centimeter. You probably already know that. Well, the C tells us that we are at centi, okay? So all of these letters are going to be the first letter in a two-letter combination. If you only have one letter for your whole unit label, then it's going to be base. If you have two letters, the first letter is the prefix on the line, and then the second letter is your base part, okay? So we're going to use this in example 1 to help us move our decimal around. Here we go. Let's try. So we have these 4 things to do, and we are going to, when you look at it, this is our start side, because we know these numbers, right? And then this is our end side. So on our metric conversion line, we have to figure out, okay, we're starting here and we're ending here. So then it tells us how many spaces we have to move our decimal, okay? So I would go ahead and, it's not written in, but it is on the assignment. I'm going to put DM stands for decimal moves, so how many times we're going to move our decimal. And then also, what direction are we moving? Are we moving the decimal right or left? Okay, so we're going to make note of this. If you get really good at this and you don't have to write it down anymore, that's perfectly fine. But it helps me to do that, and so I want to help you as much as I can. Okay, so for our first one, we have 43,000 ml, and we want to know L. Okay, well, so our L is our end, and our ML is our beginning, our starting point. So let's look at our metric conversion line. I'm going to put starting in red. So we have ML, which I'm writing this down, but I would probably not write this down on your metric conversion line. Write it in your notes. Okay, and we have ML, and we need to go to L. So NL, L is the second letter, so that's a base part of the unit. So the little m in front is our prefix. And so little m on the metric conversion line is milli. So we're starting, don't write this down, we're starting at milli. So put your finger on milli, okay? Milliliter, because L stands for liter. Then we need to go to liter. There's no prefix in front, it's just one letter. So that means that we're stopping at when we hit base. Okay, so we're starting at milla and we're going to base. So let's count how many times we have to move until we get to base. We have 1, 2, 3 times that we've got to move. So back on our note packet, we are moving. So we said we're moving 3 times. And did we move right or left? We moved to the left. So I'm going to put an arrow pointing left. If you would rather write an L, that's fine. But I find for me, writing the arrow pointing in the direction I'm supposed to move helps me and it's less thinking. Okay? So now this is when we can actually do the problem. Okay? We need to find where our decimal originally is in the number. So if it's 43,000, there's no decimal, so we imply that the decimal's at the end. And then I have to move it 3 times left. So I'm going to go 1, 2, 3. Now, I'm left with a 4 and a 3, and then that's where the decimal place goes. So the other zeros are kind of canceled out. Don't need them anymore. Okay? So 43,000 milliliters is equal to 43 liters. Well, let's move on to the next one. Hopefully this will kind of get easier as we go. Okay? We have 0.0028 s equals how many that thing s. Okay? Well, so let's think about our units. We have s, and we have, it looks like a u or an m. That's actually called micro s. Okay? So we are starting at s. We're going to the micro s. So let's look at our metric conversion line. We are going from s to that thing. Okay, so s is a letter by itself, no 2 letters, no prefix. Means that we're starting at the base. Okay, and so put your finger there. And we need to go to this U-ish kind of looking thing. It might look like an M kind of when I read it. That is called a micro. So it's microsecond. So we're going from second to microsecond. So to move between those, how many times do we move? Starting at base, we go 1, 2, 3, 4, 5, 6 times to the right this time. So 6 to the right. So I have 6 moves to the right. So that means this time I have my decimal that's on the page for me. So I'm going to start here and I'm going to move 1, 2, 3, 4, 5, 6 times. Okay, so since I moved my decimal over, all the zeros don't matter in front anymore, to the left. So I have my 2 and I have an 8. Then I have 2 more spots that are empty. Well, like you learned back in math class, you spot fill zeros in those 2 spots. So we have 2,800 or 2,800 microseconds is equal to the 0.0028 seconds. So those both involved base. Let's now not incorporate base as a start or an end point. Okay, so we have 5.30 Hg, and we want to know how many lowercase d g that is. Okay, so we have our start and we have our end. Let's look at the metric conversion line. All right, so we're going from Hg to lowercase d g. Okay, so my starting point, H. G's, what do they stand for? G's are both grams. So H is hecto. Whenever I think of that, I think of Hector Zeroni from Holes. So that's our start point. Okay, so I'm starting at hecto, and I want to go to lowercase g. Lowercase g, or lowercase d, sorry, is deci. So I want to go to deci, not deca, because deca is capital. I'm going to stop at deci. Alright, so it's time to move. Starting at hecto, Zagroni, 1, 2, 3 times to the right. So I have 3 moves to the right, so I'm going to go 1, 2, 3, and so I have 5, 3, 0, and I have one more 0 to spot fill, so it's 5,300 decigrams. Last but not least, 308 m is equal to how many capital M lowercase m's? So remember, we have our start, we have our finish. At your conversion line, what do we do? So we're starting with a lowercase m, and we're going to a capital M and a lowercase m. Well, first off, the lowercase m that we're starting at has no prefix. It's just one letter. So that means we're starting at base. And then we need to go to big M, little m. The big M stands for mega. So that's megameters, in case you're wondering, because the little m second is meters. So we're starting at base and we need to go to mega. How many times do we move? 1, 2, 3, 4, 5, 6 times. So that's 6 to the left. 6 to the left. All right. Okay. There's no decimal point, so I'm implying that it's at the end on the right side of the number. 1, 2, 3, 4, 5, 6. Okay. So I'm going to start from the backwards. So I have 803, 308. And then I have 1, 2, 3 more zeros to put in before my decimal. Okay. So at this point, if you want to leave that like that, 0.000308, perfectly fine. I don't really care. That's great. Or you could put that 0 in front if you want to. My answer here is just going to be there because I like to look nice. But if you don't want to put that 0 before the decimal, totally fine. Alright, so that's it. That's all of our metric conversions. That's what we're doing. We're using the metric conversion line. So now we're going to do the metric conversion